In the previous section, we synchronized FPGA loops by sharing a common signal. By the end of this module, you will be able to synchronize on-demand C-series modules. Okay, so let's talk about the need to synchronize I/O, specifically C-series modules for a compact Griot. So some applications are going to require a high level of synchronization between channels. For example, if you're taking several vibration or sound measurements from multiple channels or you're doing multiple types of measurements, and you want to make sure that all those measurements are happening at the same time. So in this section, we'll talk about how you would do that. Okay, so first, let's talk about synchronizing on-demand C-series modules. And the way that we're defining an on-demand module in this slide is it's modules that use the loop timer VI to time their loop rate. Okay, so on the slide, you see some examples of on-demand modules. So for example, digital modules are going to be on-demand modules. Also, analog modules with a SAR, that stands for Successive Approximation Register, ADCs, which stands for Analog to Digital Converter. Okay. If you want to see the type of ADC that an analog C-series module uses, you can look in its specifications. So an example of that is the 9215 or the 9263. Another example of an on-demand module is multiplex modules, so 9211 and 9207. So at the bottom of the slide, you see that with these modules, the way that you time them is with a loop timer VI. And then you would put an FPGA I/O node in the next frame. So the way that you would synchronize on-demand C-series modules is you would place all the channel reads and updates in the same I/O node. So if you take a look at this block diagram, you can see that in the while loop, we've got the loop timer to time our while loop. And then we see that all of our I/O that we want to synchronize are going to be placed in the same FPGA I/O node. Okay, so you can mix analog input, analog output, and DIO channels with minimal skew. So just one thing to keep in mind, the maximum loop rate possible is limited by the slowest channel in that FPGA I/O node. So think about the different channels that you have in there. If you have a digital channel, you know that's going to execute within one clock tick. Analog channels, again, are going to require multiple clock ticks usually, right? So analog input is going to require several clock ticks. Also, if you have a multiplex module, then each additional channel that's in there, because it's multiplex, is going to require some additional clock ticks. Now you can synchronize on-demand C-series modules. Next, we will synchronize delta sigma C-series modules.